The second part is not just studying the mean. Sometimes we care about studying the proportion, because one of the parameters is the mean, the other parameter is the population proportion. So the goal is sometimes estimating the population proportion. For example, an accountant may be interested in determining the proportion of accounts payable balances that are correct. Or a production supervisor may wish to determine the percentage of product that is defect-free. We don't sometimes look at the mean, the average, we look at the proportions, the percentages, which is really common in real-life applications. A marketing research department might want to know the proportion of potential customers who will purchase a particular product. Yes, correct. We do all of these things, right? So that's why we can build the sampling distribution of the proportion, not just the sample mean, okay? Or the mean. Sampling distribution of the proportion. What is the population of a proportion? It's just dividing the number of the items over the population size. We call it P. And the sample proportion, we call it P bar, which is the number of items in the sample divided by the sample size, which is little n. Little n is the sample size, big N is the population size, and the sampling error of the proportion is P bar minus P. Just subtract them. Example. In summer of 2015, FCC approved AT&T plan to acquire DirecTV for this amount. Predictions showed that the new firm would be the largest pay TV company in the States, with approximately 26 million subscribers. Based on the statement by DirecTV's executives, its shareholders gave overwhelming support to the deal, with 99% of those voting favoring the deal. So you have 99% of the population. So this is my P, the population proportion. This is the population proportion. Population proportion. It's a proportion. It's 99%. 99%. Proportion, okay? Suppose a shareholder group decides to randomly sample 40 shareholders' proxies to see whether the share owners had voted in favor of the sale or no. So these guys favoring the sale. This is the percentage of people who are favoring the sale or the deal, right? This is the population. Now we took 40 as a sample size. So N is 40, little n. And they found that 36 of them approved the vote. So this is my X, by the way. It's 36. And the P bar, the sample proportion, which is P bar, this is P here, P bar is equal to 36 divided by 40, right? Now to find the proportion error, what is the sampling error? Sampling error is P bar minus P, which is 36 over 40. So if you divide by 4, we get 9 over 10 minus 99%, which is 0.9 minus 99%, which is 0.09. This is the sampling error. As we said, the P is the proportion of the population. The sample proportion is X over N, which is 90%. The sampling error, we just subtract these, we get this number, which is actually S negative. It's my bad, sorry. It's negative because 90% is smaller than 99%. Now we can make connections again between the sampling distributions of the P bar. The mean mu P bar is equal to the P. And the standard error, as we said, this is the central limit theorem. Standard error is equal to sigma P bar, which is equal to P times 1 minus P over N square root of all of these guys. So we can use all of this to do the sampling distribution of the P bar, okay? Theorem 5 says, regardless of the value of the population proportion P, the sampling distribution for the sample proportion P bar is approximately normally distributed, as we said, but we have to make sure that this is true. This is important, given that this fact is true. So the sampling distribution of the P bar is normally distributed, but we have to make sure that N times P is greater than 5, N times 1 minus P is greater than 5, right? And how to standardize that one? How to standardize the P bar is P bar minus P divided by sigma P bar. What is sigma P bar? Is that one. Let's take an example. Craigslist, they did an analysis to determine the proportion of apartment for rent ads placed online that results in a rental within 2 weeks. A reporter for a national publication about these types of services wishes to make the claim that the proportion of apartments rented within 2 weeks using Craigslist is 80%. This is the population proportion. This is the claim of the population proportion. I'm going to call it P, as we used to do. This is 0.8. she has selected simple random sample of 100, so this is my n equals 100. N is 100, then we are good to, because n is 100, then we can tell that the sampling distribution of p hat, p bar, is normally distributed. What did it, okay, someone's going to ask me, what does it mean by knowing that it's normal distribution? It's very important to know the distribution of your data. If you know the distribution of your data, that means you can work on your data, you can make decisions. Otherwise, you cannot do anything. You cannot do the math. You cannot find anything. So, for example, let me give you a simple example. If I give you a shape and I told you find the area of the shape, the first thing you're going to look at is what? What is the shape? Is it a rectangle or a triangle or a trapezoid? Why? Why are you asking about these? Because you need to know which formula that you're going to use, right? If I tell you that it's a square, then you tell me, okay, that's fine, just give me one of the sides. I can give you the area. If I tell you that it's rectangle, you have to tell me, you'll ask me, oh, give me the length and width, please. So that's why we need to know the distribution of the data, so we know which way or which strategy we have to go, and right? So n is 100, so the sampling distribution of p bar is normal. And what does it say? They take this sample and they track down the rental result for each. Of these 100, she found that 73 resulted in a rental within the 2-week period. So this is my x here. So p bar is 73 divided by 100. Right? Determine the probability of 73 or fewer apartments being rented in 2 weeks. The probability. The probability that this proportion is really less than or equal to 73. Okay? So this is what we're going to find. The probability that p bar is less than or equal to 73. And we can use, since n is large, then mu p bar is equal to the p, which is equal to 0.8, and standard deviation of the p bar is equal to the p times 1 minus p, which is 80%, times 1 minus 80%, divided by, what is n is 100, square root of all of this, we get 0.04. And the goal is to find this, so what we have to do is to standardize. Can we standardize this? Can we use a standard normal distribution? We have to check, we have to do something first. We have to do that one. We have to check n times p. Is it greater than or equal to 5 or no? Yes, it is, because n is 100. P is 80%. So we got 80 here, which is greater than 5. Also, we have to check n times 1 minus p. Should be also greater than 5. To make sure that we can use the normal distribution. So this is 100 times 20%, which is 20. Then we can standardize. Now we can standardize what? We can standardize p bar. So we now standardize p bar. How we standardize that one? Using the formula that we established at the beginning, which is p bar minus p divided by this. And if you remember, this is equal 0. To be specific, by the way, this is 73 divided by 0.8 divided by 0.04. This is equal negative value. So the goal is to find the probability of p bar less than or equal to this amount, which is exactly equal to the standardized value, which is easier in this case. That means we're gonna create, if you want to see the sampling distribution, is the sampling distribution on the left. This is mu p bar, which is 80, right? This is 73 here. So we're looking for this area. This is sampling distribution. This is the standardized distribution. So either use the right or the left. This is the 0, because this is the standardized normal distribution, and negative 1.7 is here. So we're going to look at this area. Same thing, either use that one here, or we use that one here. Well, this is faster and easier because we can do in Excel. We can find in the left-hand side, so you can use norm.s.dist of what? Negative 1.75, comma true, then we're done. We're going to get the probability or the area, which is basically, it's about 0.0401. So you have 4% chance that the random sample of n equals 100 apartments would produce a sample proportion less than or equal 73% that are rented within 2 weeks if the true population proportion is 0.8. So this is the conclusion. We can say there is only 4% chance that a random sample of n equals 100 apartments would produce a sample proportion of p bar less than 70. This is important. Look, 4% chance that a random sample of, if you take any random sample, look, any random sample of n equals 100, the chance is going to be 4% for the sample proportion to be less than 73% that are, the apartments rented within 2 weeks. So that are rented within 2 weeks, given that the population proportion is 80%. And again, this is the secret. This is the magic. We're talking about any sample of 100, any sample, not just for one sample. That's why there's the strength of central limit theorem and the strength of making kind of estimation here.